So applications of laws of motion. Laws of motion. Okay, so first one, let me take the horse and cart example. So we can solve the problems of horse and cart with the help of Newton's laws. Okay, so for that, let me take an example of yeah. So let me draw the horse and cart if possible. Okay. Yeah. So what I can take. I think that this is a horse. You may draw better than me, and so obviously there is a tail for this horse, and so here usually we know that the forces we move forward because of what? Because of the force applied on the surface of Earth, not horizontal. And this is going to be connect with some cart over here. So we can take from here. Okay. So this is going to connect with some cart over here. So here this cart is going to. Okay. So we have. So this is what some horse and cart example we are taking over here. So now if we take it to here, yeah. Now if we look at the force, this will apply some force on the surface of Earth, and this will give the what your required normal force, equal and opposite force from the Newton's law. This is what the force applied by the horse, and reaction you are getting. You are moving because of what? A horse is moving because of what? Because of this reaction. So if I take horizontal component, this is what going to be horizontal component of the reaction, and vertical component of the reaction is here. Okay. So take mass of horse as m and mass of cart as a small m. Okay. So now downward force, this vertical force will be managed by what? Weight of the horse, that is what mg, so they will get cancelled. So that is why horse will not move in upward direction. But if we take the horizontal, there is a horizontal force, so that is why the horse can move forward. As horse can move forward, there will be tension developing in this string. So here the direction of tension will be always towards the center. So similarly, so when that start moving, so this will start rotating. That will apply some force in opposite direction. Okay. So because of this tension, this force is coming in action. So these two are equal and opposite. And because of this force, this tension is coming in action. So because of the horizontal component of the reaction of the Earth. Okay. Now if I want to find the acceleration of this horse, I will take only horse part. Okay. So if I take only horse part, so what will happen here? If I want to find the acceleration of this horse, so acceleration of horse, okay, acceleration of horse if I want to find, so what we can write? We can write what is the forward force? Forward force is h minus what is the opposite force? Opposite force is t. So this is what going to be F net. Okay. So this is going to be what F net. So h minus t equals to what is F net? I can write mass of horse and acceleration of the horse. So acceleration of horse you can get it as the forward horizontal component of the reaction minus tension developed, because tension is opposite. So these two are equal and opposite. Tension is in this direction, h is in this direction. So the intuition is required. So take m here. So this is what going to be acceleration of the horse. Okay. So now what is the acceleration of car? I will take only this part now. Okay. So I will take only this part. So for acceleration of car, what is the forward force? Forward force is tension. Tension is forward force. and this force applied by the wheel on the floor is what? It is the opposite to the tension. So I can find T minus F equals to F net. Okay, so T minus F equals to, what is F net? Mass of the cart. This is what cart. Okay, so mass of the cart multiplied by, so it's what acceleration, sorry, acceleration due to gravity, sorry, acceleration. So this is what mass into A. So A equals to T minus F divided by M. This is what going to be acceleration of this cart. Okay, so if I take as a whole, if I take as a whole, if you want to find the if you want to find the acceleration of the whole together, cart and horse together, if that is the case, in that case what will happen? I will take this system as a whole. If I take this system as a whole, so what is the forward force? Forward force is H. So forward force is H. What is the opposite force? Minus F. So equals to, this is what? Net. Yes or no? These two will get cancelled, equivalent opposite. So forward force is F. Sorry, forward force is H. That is what horizontal component of reaction. And backward force is what? It is the F. Okay. So equivalent opposite. So I will take H minus F equals to F net. So H minus F equals to what is the mass? Mass of both I have to take. Mass of cart plus mass of horse. Okay. So mass of horse plus mass of cart into net acceleration, total acceleration of the system, because both are moving with the same acceleration because they are connected. Okay. So acceleration of the system is what? H minus F divided by so M minus, sorry, plus M. So this is what going to be acceleration of cart and horse together. Okay. So this is only for acceleration of horse. This is only for acceleration of cart. So this is acceleration of cart. This is for what? Acceleration of the whole system. So this is for acceleration of whole system. So together if you take, you can use that formula or you can use the individual formulas. Okay. So this is how we can see the application of Newton's laws in our day-to-day life. This is a small example where we can see or we can find the acceleration of different bodies which are connected. Okay. So one more very popular example I will take, that is what we call it as pulley block problems. Okay. Suppose there is a pulley and this side one mass is connected which is of heavy, so or we can say which is of light. Okay. So one mass is there, I will take it as M, and one more mass I will connect it here. So this is what going to be heavy one, M. Okay. So I will write M greater than M. So if M greater than M means in which side it will move, it will start moving in this direction. Okay. So this will start moving upward direction because M is greater than M. So which side is heavy, that side it will start moving. Okay. So if that is so, obviously tension will develop in the string. Direction of tension is this one. So it is same string. It is the same string. I will connect it here. So this is what horizontal. So if it is the same string, so same tension will come here. Okay. If you use the different strings or different bodies in between, that will be different. So this is what the tension so acceleration, it will move in this direction. Say acceleration is A. Then what about its acceleration? This is also going to be A only. Why? Because both are connected. Because both are connected and there is no in between bodies. As in our last example, your cart and horse have the same acceleration. Here also the mass M and this M have the same acceleration. Okay. So to find the acceleration of this system, we can use our laws of motion. What is the downward force acting here? Downward force acting is nothing but its weight. Weight is what? Mass into acceleration due to gravity. What is the upward force here? Upward force is nothing but your tension. Okay. So you are talking about only this system. Don't worry about this direction. For this system, tension is in upward direction. Okay. So can we write the net force on this one? Net force on this one is downward force is mg. Which is greater here? Mg is greater than T. How? Because it is moving downward. On which side force is more, on that side body will move. Obviously we can take mg is greater than t. So what I will write? I will write it as mg minus t equals to F net. Okay. So mg minus t equals to can I write m into a mass of this body block and acceleration of that block. Okay. So I got one equation. So suddenly here you can't get acceleration because t is also unknown and a is also unknown. Okay. So similarly, if I come to the this second body, it is moving in upward direction. That means tension will be more. Tension T will be more, and downward is what? M into Z. So I can write T is greater than mass into G. The tension upward is greater than its downward force. That is why it is moving in upward direction. So I can write as T upward is more, downward is less, minus mg equals to F net. So T minus mg equals to M into A. So this is what the second equation. If you solve these two equations, you can get the what? You can get the acceleration. So how you can get the acceleration? Adding these two. If you add these two, equation 1 plus 2, what will happen? Minus t plus t will get cancelled. So what remains is m into z minus m into z equals to this one, m plus m into a. Okay, this plus t and minus t will get cancelled. Okay, so what you can write? G you can take common. So m minus m into z equals to m plus m into a. So acceleration is mass of the heavier body minus mass of lighter body divided by mass of heavier body plus mass of lighter body into z. Just I am taking on this side. Okay. So this is what going to be the acceleration of the system, acceleration of body 1 or body 2, whatever you can take. Okay. So that is what the acceleration. So this is what acceleration we got. Then you may ask me, can we find the tension from here? Obviously, if you substitute the value of A in the equation, you can get tension also. You can either use first equation or second equation. Here T is positive, I will go with second equation. So what is that? T minus mg equals to, so this is what m into A. So T equals to ma plus m into z. Okay. So m into A. So A I will substitute this one. Okay. So m into m minus m divided by m plus m into z. So plus m into z. Just I am substituting value of A in the second equation. Okay. So T equals to, take mg common, m into z. Here also mg is there. Mg I will take common. So what remains is m minus m divided by m plus 1. Okay. So T equals to mg m minus m plus m divided by, so m plus m. Okay. So m will get cancelled. So what remains is 2 times m into z. Okay. 2 times m. So this m will be there as it is, divided by m plus m into z. Okay. So this is what going to be tension. You can, if you substitute here, then also you will get the same answer. So you can you got the both tension and acceleration as well. Okay. So this is how you can solve the problems with the help of net force. Let me take a simple pulley block example. Again, we will solve during our numericals. So say this is of say some 5 kg and here it is of say some 2 kg. Okay. So 5, obviously 5 is greater than 2, it will move in downward direction. So what is the acceleration? I will take it as A. What is the downward force here? Downward force is mg, that is mass is 5, g I will take it as 10. G I will take it as 10. So 10, that will become what? 50. So downward force is 50, upward we don't know, it is tension. So here and here it is moving in upward direction, that is what acceleration, same acceleration you have to take. Downward is 2 into 10, so that is what? 20. So upward is what? Again tension. Obviously here what I can write? Net force. Net force I can write it as downward is what? 50. upward is T equals to mass into exertion, 5 into A. 5 into A. This is what first equation. Second equation will be what upward force is more. So T is more minus downward force is 20. Downward force is 20 equals to mass into acceleration, that is 2A is the second equation. So you can solve these two equations. Why I am giving this method is, don't need to remember that that formula A minus M divided by N plus M into Z, not required. You can apply your basic method. You can find the answer. Okay. So no need to by hand the formulas. Okay. So solve these two equations. What I will do is I will add these two equations. If I add these two equations, what I will get? I will get it as this T will get cancelled, 1 plus 2. If I add these two equations, minus T plus T will get cancelled. So 50 minus 20 equals to 5A plus 2A. Okay. Just I am adding. Okay. So now this will become what 30 equals to, this will be what 7A. Okay. So what is acceleration? Acceleration is going to 30 by 7 meter per second square. This is what the acceleration, 30 divided by 7, because 50 by 20 is 30, so 5 plus 2 is 7. 30 by 7 is going to go to your acceleration. Then what about tension? So tension T equals to, so 2A, this will become plus 20, okay. So 2A is what? A is 30 by 7 plus 20. So how we can solve this one? This will become out 60 divided by 7 plus 20. So 60 plus 7 2 is 140 divided by 7. So this is going to go out 200 divided by 7. This is what Newton, because tension is what? Tension is nothing but a force. So this is how we can you can simply easily solve the numericals based on block and pulley. So no need to remember that complicated formulas. Okay. So one more again our day-to-day life problem we can take. Suppose most of time the what as we already discussed, the weight of the body, that is what M into Z is equals to what? Is equals to equivalent opposite to what? A normal reaction. You can take it as N or R, whatever. So normal, let me take N only instead of R. So normal is equals to what? Normal is equals to M into Z. That means weight is equals to what? Normal reaction. If we take wise magnitude, it is equals to the normal reaction. So whenever we are measuring our weight from the weighting machine, that is showing you what? That is showing you the normal acting on you. That is equals to normal acting you. And you may also observe when we are moving in the lift, we will feel sometimes more weight, and in other direction we will take the less weight. We will see what will happen. Suppose a lift is moving in upward direction. Suppose lift is moving in upward direction and you are standing over here. Say your mass is M. Your mass is M, and lift is at rest or constant motion. Rest or constant motion. If it is at rest or constant motion, or means uniform velocity, acceleration is what? Acceleration is going to 0. What is the downward force? Downward force is equals to mass into acceleration due to gravity. Upward force is what? Only normal reaction. Already you know that normal reaction is equals to what? It is equals to weight. So M equals to weight equals to M. So M equals to what? M into Z. M into Z. So when the lift is at rest or moving with a constant motion, the apparent weight is equals to what? The actual weight. This mg is what? Your actual weight. When you are outside, the actual weight is what? Actual weight is equals to mg. So when you go in the lift, if lift is at rest or moving with constant velocity, what will happen? The apparent weight means weight inside lift is equals to, apparent weight is equals to what? The actual weight, means weight outside the what? Lift, actual weight. Okay. Instead of that, if a lift is accelerating upward, so now what will happen? Suppose you are inside the lift and you are standing over here. So what is downward force acting? Downward force acting is mg. Upward force is what? Upward force is normal reaction. Then acceleration is there. Acceleration is in upward direction. Okay. That means there are two forces acting in upward direction. Okay. Or if you want to find the net force. So what is the net force here? Net force is equals to, so since it is moving upward means what is the net force? Net force is equals to what is that? It is moving upward means the upward force is more, so that is what? Normal minus m into g. Normal minus m into z. So what is the or simply you can write mg is equals to this plus this also. Okay, so total upward force. So what is the F net? Acceleration of the lift means that is equal to acceleration of u also. So mass into acceleration n minus mg. So n equals to what? N equals to mass into acceleration plus mass into acceleration due to gravity. So n equals to m into a plus g. M into a plus g. That means weight is equals to what? Weight is equals to, normal is equals to what? Mass into acceleration plus acceleration due to gravity. That means weight is what? Weight increases. That means apparent weight is more than where I can write here. Apparent weight is more than actual weight. Apparent weight is more than actual weight. That is why when lift moving in upward direction, you will feel that your weight increased. Okay, so the weight increases when the lift accelerating in upward direction. Okay, so weight increases when moving in upward direction. So if I take lift moving in downward direction or accelerating in downward direction, we cannot say simply moving. Okay, so accelerating downward. Accelerating downward means, so what is this? You are standing over here, your weight is mg, acceleration is downward direction. This is what the normal acting. Okay, so now F net is equals to it is coming downward means mg may be greater, mg minus of normal. Okay, so what is the F net? Mass of this person and acceleration. So m into a equals to mg minus n. So take n on this side. So what will happen? Mg minus m into g. M into a. You can take it here. So what will happen? Normal equals to m into g minus a. Okay. So g minus 8 is going to be. So that is why weight is equals to mass into g minus a. That means it is less than actual mass. Actual mass is what? M into g. Here it is becoming m into g plus a, increasing. Here m into g minus a, that means decreasing. That means what you can write here is apparent weight. Apparent weight is less than actual weight. Okay. So here what will happen in first case? Weight is same as the actual weight. When you are moving in upward direction, when you are accelerating upward, weight increases. When you are accelerating downward, weight decreases. That is why when lift started moving downward, you will feel like very light. So that is what the apparent weight is what decreasing. When lift is accelerating upward, you will feel that your weight is increasing. So it is not like that. It is what changing with the acceleration. Okay. One more thing related to lift. Suppose lift A equals to 0 means weight equals to mass into acceleration due to gravity. If it is moving upward, then weight equals to mass into z plus a. Suppose if it is moving downward, so weight equals to mass into z minus a. Okay, so accelerating downward. Suppose lift is under free fall. Suppose what you can say, lift is under free fall. If lift is under free fall means what? The lift is accelerating downward with acceleration equals to acceleration due to gravity. Acceleration equals to acceleration due to gravity. Now person is standing over here inside. Okay, now if it is accelerating downward, what is the formula we are having? Weight equals to mass into g minus a. But when it is under free fall, since it is free fall, so what will happen? If it is free fall, a equals to what? G. That means it is moving in downward direction with acceleration equals to acceleration due to gravity. Okay. So what will happen? So weight will be m into g minus a. A is equals to what? G. So this will become what? 0. So your weight will be 0. That what we call it as? We call it as weightlessness. So weightlessness. Okay. So we will experience weightlessness. We'll feel like we don't have any weight only. So that is possible when lift is moving downward with acceleration equals to acceleration due to gravity. Okay. So that is what you will feel like. You will feel like weightlessness. Your weight will be 0. Suppose if it is moving exerting upward with a equals to g, then your weight will be what? It will be 2 times your actual weight. Okay. So like this we can if they give the mass and acceleration, you can find their weight. They will give the different cases. So all those things we will discuss again when we go for the numericals. But remember these are the what